All right, welcome to 4.3.1, derivatives of inverse trig functions. Just as a reminder, if I have something like y equals sine of x, that is a trig function. The inverse function would look like this, y equals inverse sine of x, right? So trig functions, you put in some angle and get out a number. For instance, if I have the sine of pi over 2, that's equal to 1. So with a regular trig function, your input is some angle and your output is some number. In an inverse trig function, it's the inverse function. It undoes whatever the trig function does. So it'd be the exact opposite. I'd have something like the sine of 1 is equal to pi over 2. You put in some number and you get out some angle. Inverse functions undo the original, so it should come as no surprise if I had the sine of the sine inverse of x. That would just be equal to x because the sine and the sine inverse functions will undo each other. Just like if I had multiplying by 2 and dividing by 2, those are inverse operations. Multiplying and dividing are inverse operations, and so they kind of undo each other. Same thing with inverse functions. Heads up, that is pronounced inverse sine. It is sometimes also pronounced arcsine, and it's sometimes written as y equals arcsine of x. It's just another name for it. The calculus stuff normally sticks with that terminology, inverse sine, where you use that inverse symbol right there. Also, please note that is an inverse symbol, not an exponent. It's different than sine to the negative 1 power. If there's ever a negative 1 there, that is not an exponent. Hey, Chica, one moment. That is not an exponent. That is an indication of that it's an inverse sine function. If you had to write negative 1 as an inverse and you wanted sine to the negative 1 power, you would write it like this, all to the negative 1 power. Right? That is not the same thing as this. You write that, that's sine inverse of x. All right, this page has gotten kind of messy, so I'm going to erase that stuff, and we're actually going to start talking about the calculus of inverse trig functions and how to find the derivatives of inverse trig functions. One moment. Okay, so we already should know the derivatives of our trig functions. So if y is equal to the tangent of x, we should know that the derivative of tangent of x is secant squared, right? Today, we're going to be learning the derivatives of the inverse trig functions. In other words, if y is equal to the tangent inverse of x, or the arctan of x, what would the derivative be equal to? And that's what we're going to find out. So here is y equals tan inverse of x. At this point, I don't know what the derivative is, so we are actually going to figure this out with stuff that we do know. So since I can't find that derivative, what I would do to figure this out is I would take the tangent of both sides. I'd take the tangent of y and the tangent of the arctangent of x. So I'm taking the tangent of both sides of the equation. The reason I'm doing that is because tangent and arctangent are opposite functions. So those are going to go away. They're going to undo each other. And I'll end up with the tangent of y is just equal to x. Now I'm going to take the derivative of both sides because I do know the derivative of tangent. So the derivative of tangent is secant squared. So this would be secant squared of y times the derivative of the inside. Well, derivative of y is dy dx. This is called implicit differentiation again. When you don't have a nice y equals equation, you got y in there. Equals derivative of 1x is just 1. And yes, I could use the chain rule and say dx dx there, but of course dx dx is just 1. So we just write it like that. I wanted the derivative. Well, dy dx stands for the derivative of y with respect to x. So dy dx is equal to 1 over the secant squared of y. And now that is my derivative, but it's kind of an unfortunate derivative because it's defined in terms of y, and normally we like our derivatives to be defined in terms of x, right? Luckily, we actually can keep going. There is a Pythagorean identity that I can rewrite secant squared of. You might have learned this in pre-calc. In fact, I know you did because I taught it in pre-calc. The Pythagorean identity for secant squared is 1 plus tangent squared. So I can rewrite that secant squared as 1 plus tangent squared. And the reason that's super helpful in this particular case is because of right up here. Oops. Because right there. The tangent of y is equal to x. Well, that's just the tangent of y squared. So that's just equal to x squared. I can finish this up and say my dy dx is equal to 1 over 1 plus, instead of writing tangent squared of y, since tangent is equal to x, I can write x squared. That is the tangent. That is the derivative of the inverse tangent function. That is the derivative of arctangent. Now I find it kind of cool because this was a weird inverse tangent function, and when I find the derivative, it's actually just something in terms of x, an equation defined in terms of x, which I think is cool. Now this is a long way to do it, and we could do this for every inverse trig function ever, but it would take a whole lot of time, and it would require us to remember all these trig derivatives really, really well. Sorry, all of these Pythagorean identities really, really well. And turns out we can do that every time, but once we do it once, it's easier to just memorize the trig inverse derivative. So just like we memorized our derivatives for trig functions, we are going to have to memorize our derivatives for inverse trig functions. I'm not going to go through this entire setup every time for all 6 of them. If you really wanted to, you can on your own. It's good practice. But instead, I will show you what those trig derivative functions are. So derivative of arctangent is 1 over 1 plus x squared. The rest of them are right here. I would spend some time making sure you memorize these and understand them. Again, I've used u this time, but that's no different than x. So d du stands for the derivative. So the derivative of arc sine is this thing, right? Derivative of arctangent, we already talked about, 1 over 1 plus. Here again, I used u instead of an x. So u squared or x squared or whatever your variable happens to be. I used u in this case just because sometimes there's something inside of that, and it kind of helps people remember that chain rule is a thing. So you might have to use the chain rule. We'll do some examples like that. But here are your 6 inverse trig derivatives. Definitely memorize them. Again, there is a nice correlation with sine inverse and cosine inverse, tangent inverse and cotangent inverse. If you take a look at those, sine inverse is all of this stuff. The derivative of cosine inverse is the exact same thing, except negative. Derivative of tangent inverse is 1 plus over 1 plus u squared. Derivative of cotangent inverse is the exact same thing, but negative. Same pattern holds for secant. Same exact thing, except a negative 1 on the top. So if you can memorize these 3 derivatives, those 3 should be easy. Same exact thing, but opposite sign. All right, let's actually do a few. This one, find the derivative of tan inverse of square root of x. So if I were to do this problem, I would probably rewrite that function. I would rewrite that as f of x equals the tangent inverse of x to the 1/2. Because we should have hopefully learned by now that a lot of times when doing calculus, it's easier to have an exponent in that place instead of having a square root function. We tend to prefer exponential form over radical form when it comes to calculus. All right, to also make it a little bit handy for me, I am going to write the tangent inverse derivative off to the side, just as a reminder. It's right here. So the derivative of tangent inverse of u, so dx of tangent inverse of u is equal to 1 over 1 plus u squared. All right, so this is a tangent inverse function. So the derivative, f prime of x, is going to be that exact same thing, 1 over 1 plus u squared. In this case, 1 over 1 plus, that's my u, x to the 1/2 squared. That's why, and when I wrote these tangent inverse functions, I didn't write an x because it can be really tempting to put an x in this spot. But it shouldn't be an x squared, it should be x to the 1/2 squared because that's the thing that's inside my function. All right, so chain rule says you take the derivative of the outside, multiplied times the derivative of the inside. I just took the derivative of the outside. So now I need to multiply that by the derivative of the inside. So multiplied by, well, the derivative of x to the 1/2 is 1/2 x to the negative 1/2. I'm essentially done here, but I can do some pretty nice simplifying. In this case, it's going to be 1 over 1 plus x, because x to the 1/2 all squared, right? That's just going to be x. Times this, I can rewrite that negative exponent in the denominator. It's sometimes useful to do that. So 1 over 2 x to the 1/2. I could write it as x to the square root to start 2 square roots of x, but I prefer exponents, so I'm going to leave it like that. I might as well combine those into a single fraction though. 1 over 2x to the 1/2 times 1 plus x. There it is. Let's try another one. Sine inverse of x cubed. All right, off to the side, I'm going to rewrite my derivative for sine inverse of u, just as a reminder, so we have something to look at. So let's see here, going up here, there it is, right there. It's a 1 over the square root of 1 minus u squared. So that's 1 over the square root of 1 minus u squared. All right, so for this one, g prime of x be the derivative of the outside first. Derivative of sine inverse is this function right there. So it's going to be 1 over the square root of 1 minus, but instead of u squared, there's my u. So x to the 3rd squared multiplied by the derivative of the inside. Well, that x to the 3rd was my inside, so the derivative of that would be 3x squared. Again, I could simplify this. If I multiply those two together, 1 times 3x squared is 3x squared in the numerator, all over the square root of 1 minus x to the 6th. Just like that. That's the type of stuff you're going to be working on today. There's one type of problem I should probably talk about that talks about the equation of tangent lines, also a good one as a reminder. So this will be our last example, and then you can get started in the homework. This one says, find the equation of the tangent line to that curve, the y equals arc cosine of x at x equals 1/2. Anytime I want the equation of a tangent line, right, it requires two things. It requires a point and a slope. So stuff we've been doing forever. We need a point and we need a slope. To find the point, you just plug your x value in. So it's going to be 1/2 comma whatever the cosine inverse of 1/2 is. That's something that we can definitely do without a calculator. If you remember your unit circle, cosine is your x value. So I'm looking for an x value of 1/2. So that would be on the unit circle right there. That's 1/2, and that's square root of 3 over 2. It's cosine inverse, that gives me the angle. So I got to remember what size angle that is. If If you remember, that is a pi over 3 angle. So the cosine inverse of 1/2 is pi over 3. This might be a good review for you to remember how to find the cosine inverse of different angles. Again, cosine inverse happens only on the top half of the circle. That might look familiar to you. I'm not going to spend a lot of time in this video talking about that. At this point, if you just wanted to put it in a calculator and get pi over 3 out as well, that's fine. But this is something that I expect you could figure out if need be by hand. All right. So this is the same as 1/2 comma pi over 3. All right, the slope. Slope is going to require the derivatives. So I got to find the derivative of cosine inverse. Well, y prime, that's something that's written up here. Let's take a look at it. Cosine inverse right there, same as sine except negative. So a -1 over 1 minus u squared. In this case, my u is just an x though. So 1 minus x squared. Particularly, I want the derivative at that 1/2. So I want the derivative evaluated at 1/2. So that'd be -1 over 1 minus 1/2 squared. That's the same as -1 over 1 minus 1/4. Which is equal to -1 over 3/4. Which is equal to -4/3. All right. Got my point. Got my slope. I can write the equation. Y minus the y value equals slope times x minus the x value. There's my tangent line. All right. This stuff here, finding the cosine inverse of 1/2, that's something maybe we'll talk a little bit more during the live session. The bigger thing that I'm worried about this time, just because it's new, is making sure you get these trig derivatives memorized. Right? So I would write them down, maybe do them on a flashcard, memorize those 3 on the left. If you can memorize those 3 on the left, the ones on the right will be easy because they're the same exact thing except negative. All right, that's it. Here's your assignment. 4.3.1, 1 through 25 odd. See you later.